This presentation is delivered by the Stanford Center for Professional Development.
Alrighty, so with that said, I want to do just a tiny little bit of wrap up on what we talked about memory and this whole notion of pointers last time and go into our next great topic. Alrighty, so time for our next great topic. Well, we need to do a little bit of pointers first. So the first example is something that we talked about very briefly last time, but I want to make sure everyone's sort of on board with this. So if I have our friend the point that we talked about last time, which is just a class that stores two values, an x and a y, that we pass into the constructor, when we do something like this, I'll draw it sort of over on this board, and I'm going to draw it in a, actually I'll draw it over here. And I'll draw it in a way that we don't need to worry about all the memory addresses and overhead and all that stuff, because that sometimes makes the diagrams a little bit ugly. And so I'll show you the very simple stylized version of keeping track of the stack and the heap. So over here is the heap, over here is the stack, and what we're going to do is say, hey, when we declare point P1, before we have done this new, what we get is P1, which is basically just some box on the stack. What does it hold right now? Well, until we do this line, it holds nothing. It holds nothing that we know about. Okay? When we call this new, it says, hey, heap, get me some new memory for a point. So the heap kind of goes over here and goes, boink, here's some memory for a point. And it calls the constructor and says, hey, constructor, put in the values 1, 1. So somewhere on the heap, we have the values 1 and 1 for our little private x and our private y somewhere on the heap. And the value that new gives back that we assign to P1 is the address of this thing. Remember, we don't really care about where in memory this thing's actually stored. And so sometimes what we like to do is just keep track of addresses by pointers. So we know that this is just some memory address over here where this particular object's actually stored on the heap. Okay? So now if we do point P2, actually let me not put the semicolon on yet. If we do point P2, what we get is on the stack, we get some new space set aside for P2. And again, its beginning value is unknown. Now we have a couple options. One thing we could do is say new point and give it some xy location, in which case we'll get a new point on the heap, and P2 will point to that new point. We could do something funky like say, hey, P2 equals P1. Well, all that's happening there is saying take the value that's in P1, which is a pointer over to this location on the heap, and set P2 equal to that. So if this happens to be a memory location, you know, AAAE, this guy gets AAAE, which means in our sort of stylistic representation, it's pointing to the same place. Okay? Are we sort of on board with that? If you're on board with that, nod your head. Excelente. All right, so now if we do P2.move and we tell it to move by an amount like 3, 4, it says, oh, well, in order to call the move method, I need to call the move method using the object P2. Where does the object P2 live? It looks it up through the pointer and says, here, this is where you live. Call the move method with this particular object. So it passes this pointer to this location in memory, and it says move 3, 4. And as you saw with move last time, all move does is add those values to the respective x and y. So px becomes 4, py becomes 5, and now that move method's done. And interestingly enough, what I've done is changed not only P2, but also P1, because they're pointing to the same place in memory. They're the same actual point. And that's the important thing to keep in mind. If I set an object equal to another object like this, they're the same actual object. There's only one of those objects that lives somewhere, and I really have two things that are pointing, or what we like to refer to as referring to that object. So oftentimes we refer to these things as references. Okay? Now what happens if I come along and say, point P3, I get P3 over here on the stack, right? And again, I'll write the P3 over here so as not to interfere with the lines. And I'll draw this line a little bit around P3, so it kind of goes like that. It says, oh, P3, yeah, I don't want to interfere with you. I'm just going to zigzag around. P3, what value does it start with? I don't know. It's not pointing to an object yet because it hasn't been initialized to point to an object, hasn't been initialized to point to a new object. And so if I come along and say, hey, you know what, P3, I just want to move you. You know, move to 4, 5, because that's where I hear the party's at. That's where P1 and P2 are. Can you move yourself to 4, 5? What happens when I do this? Bad times. That's what happens. What I get, well, first of all, I get a social because a whole bunch of people said it. But what I get is this thing Who knows where it's pointing? As a matter of fact, this pointer could oftentimes be something we refer to as a null, which means it's not pointing to any particular object, in which case when I try to do this, I get what's called a null dereference. Anyone happen to see something called a null dereference while you're working on Breakout? For you folks? Yeah, this is what you were getting. You had some object here that wasn't actually pointing anywhere, and you were trying to call a method on it. It says, hey, I'm trying to call the move method on P3, and P3 says, I got nothing for you, man. I got nothing here. You're trying to move something that doesn't exist, so you're trying to dereference, which means go through the reference, just a funky name for go through. We say dereference, something that doesn't exist. Or maybe this is just, has some random value that's pointing off somewhere into memory that you don't know about, which isn't actually an object. Okay, so that's what you want to watch out for, is this is real bad times if you actually happen to call a method on some object which doesn't really exist. Okay. Now, the other thing that's important about seeing these little pointers is the fact that, remember when we talked about parameter passing? And in the days of yore, we talked about parameter passing, and we said this little thing where we said, hey, you know what? If you have something like an integer or a double or a car or a Boolean, these are what we refer to as primitive types. They're like hanging around. They're, lower on the evolutionary ladder. They're just what we refer to as the primitive types. When you pass primitive types as parameters, what you are getting is a copy of the value of the primitive type. Okay? What does that mean? It means when I call some function and I say, hey, function, I'm going to pass to you a 3, like in my move method over here, I pass in a 3, which is an integer. What actually happens when I make this method call is I pass a copy of the 3. And so if in this move method I try to change this value around to something else, all I'm doing is changing the copy. I'm not changing the actual parameter that was passed in. So if this wasn't a value, let's say I actually had some variables here, like x and y, and up here I had int x and y. When I make this method call, I get copies of whatever values are in the boxes for x and y. And so if move tries to muck with x and y, all it's changing is the copy. It's not changing the x and y out here, right? That's what we talked about a long time ago when we talked about little Meron, who went off to France with his mom and the Mona Lisa, and he wanted to take a hacksaw to the Mona Lisa, but the Mona Lisa, he just got a copy because they went to the gift shop. Yeah, primitive types, you go to the gift shop. Now, something funky happens, though, when you're dealing with objects. Okay, so when you're dealing with objects, they are not primitive types, they are objects. And so when you make a method call where you pass some object along, what you are actually doing is you are passing the object, or actually what we refer to is the object reference. What does that actually mean? What that means is, let's say I were to call some method over here where I actually pass in a point. So let's say there's some method over here like, I'll call it change 0, which is supposed to set a point to be 0. And I pass it p1. And this is just some method that I wrote. And maybe the elements of a pointer are actually public, let's say, as opposed to private. So this function can actually access those things. What happens when I pass p1? Well, what happens when I pass p1 to this change 0 method, or this change 0 function, is I'm passing where p1 lives. So the parameter I actually pass is the address that's in here. So if the address that's in here is, let's say, the value, A000, I pass as my parameter A000, which means what I have is a reference, because I have that pointer, to where p1 really lives in memory. Which means if this method decides that it's going to muck around with p1 and tell, hey, p1, move yourself to some other location, the values that it's going to change when it makes method calls on the parameter that's passed in is at this place in memory, because it knows where this place in memory is, right? You want to think about when you're passing objects, this is, as we talked about it before, sort of like the mafia. When you pass around objects, you're talking to the mafia. And when you talk to the mafia, they know where you live. Okay? They can come in and mess with you however they want. They're not getting a copy of you. It's not like you go to the mafia and you're like, oh, I'm going to send my clone along to the copy, and or my clone along to the mafia, and they'll just talk with them. No, when you're going to go talk to like the godfather or the godmother, you're not sending in your clone. You're going in yourself, right? And you're like, hey, godfather, and he's like, oh, you come here on the day of my daughter's wedding. Anyone seen the movie The Godfather? It's so good. If you haven't seen it, go see it. But we won't talk about that right now. What we will talk about is the fact that if they know where you live, any changes you make are not to a copy, and that's a critical idea to know. This is what we refer to up here as pass by value, because what you're getting is just a copy of the value. You're not getting the reference. This is what we actually refer to as passing by object reference. So I'll just change the here to a by, which means that when you pass objects around, you're passing a reference to the object, you know where the object lives. Here's a little way you can think about it. So remember our story about little Meron who goes to see the Mona Lisa? Think about it this way. When little Meron went to see the Mona Lisa, again, here is the Mona Lisa, smiling. Here's little Meron, bow-legged Meron, ponytail, chainsaw. When he wants to actually, if the Mona Lisa were just some integer, right? He's going to go to the gift shop and he's going to get copies. But the Mona Lisa is actually something that's really valuable. So what do we do with the Mona Lisa? It's encapsulated in this big safe that's an object. And so when we want to say send the Mona Lisa over to like the MoMA in New York, not that they would actually display it at the MoMA, but let's say we send it to the MoMA in New York, we're sending the actual Mona Lisa. We're not sending a copy of the Mona Lisa, we're sending the actual thing. So then in the MoMA in New York, Meron comes along and says, hey, you know what, security's much more lax here. I'm just going to chop this thing up. So it takes the chainsaw to the Mona Lisa and chops it up. And that's the real Mona Lisa. So when we're done with it being displayed at the MoMA, and it goes back to our friend the Louvre in Paris, so here it is in Paris, yeah, it's still sliced in half. Bad times. Major international incident. Okay? Don't let this happen to you. If you're going to mess with an object that's passed around, to know that you're changing the actual object. Okay? So one thing you might say about this is you said, hey, Meron, you were talking about Mona Lisa encapsulating that in an object. So if I have some integer and I actually wanted to change it, could I create an object around an integer and then pass the object and allow someone else to change the integer inside that object? Would that work? Yeah, in fact, that would. And if you're interested in doing that, there's an example that does exactly that on page 235 of the book, just because it's important to memorize every single page of the book. But it's there. Okay? I just had to check. Yeah, it's 235. So just something you should know. So any questions about that? Alrighty. So last but not least, one other thing I should mention, since we're on the subject of saying, hey, why not take one of these primitive types and encapsulate it inside a class? It turns out Java actually has a bunch of classes already built in, which are encapsulations of these data. So for an int, there's something called integer with a capital I in the full word, which is actually a class that stores a single integer. The only unfortunate thing about this class is you would say, hey, now I can create integers and I can pass around an integer and change the integer, right? This class doesn't actually give you any methods to change the value. So it doesn't get you the effect you want. We'll use them later on in the quarter for something different. But just so you know these exist, there's a double, and then there's the class version, which is actually uppercase double. So Java is case sensitive, and if you ever put uppercase double, you would actually have been using the class version of it. Similarly with Boolean, there's Boolean and there's uppercase Boolean. And then with car, it's a little bit different. We have car over here, and here it's the full word character is the class. So these are sort of the class equivalents. These are the primitive equivalents. For everything we're doing so far, unless you get told to use the class equivalent, just use the primitive equivalent and life will be good. This is just kind of an artifact of programming languages. Sometimes in life, things just happen to happen this way, and you get two versions of something just because that's the way life is. Okay? But these class versions, remember like strings, we said strings were immutable. You can't actually change the string in place. All you can do is create a new one. These classes are all also immutable. Once you create an integer and give it some initial value, you can't change that initial value. If you want to say, hey, I want to take that value and add 1, you need to create a new object of type integer, which has the old value plus 1 added to it, and you get a new object. So they're immutable in the same way strings are immutable. You create new ones. You can't change the value once you've gotten an initial value. So any questions about this? Or any questions about this whole notion of pointers and references and passing this stuff around as parameters? Because if not, it's time for our next great topic. And our next great topic is something that really is a great topic in computer science because it's something you've been doing this whole time. And now it's time to lift up the covers and say, hey, you know what? There are some much more dangerous things you can do than you've been doing right now. So before we sort of gave you the safety scissors, where that has like the rounded corners and they're like rubber. Remember safety scissors? They were fun. I liked safety scissors. Now basically we take the safety scissors, we take them to the mill, we sharpen them up real sharp. We have you hold them up and run with them. Okay? So here's where things get dangerous. Files. You're going to learn how to read and create files as well, which means the opportunity to erase files or write over them, which is why things get dangerous. But it's really not that dangerous as long as you're careful, right? When you're running with scissors, just point them down and things will be... Why people ran with scissors just made no sense to me, but... Like, oh, I really need to go cut this piece of paper. Come on, we're all going. It's the paper cutting marathon. All right, so files. What is a file? You've used files the whole time, right? When you created some program, like you had myprogram.java, that was just stored in some file somewhere. And when you write a paper, in your favorite your favorite word processor, which may or may not be a Microsoft product, you're creating a file, okay? And in Java, you should be able to create files and read files as well. So that's something we're going to do. And the first thing we're going to think about is reading files. Now, the files we're going to think about reading are not necessarily Java files. We're actually going to think about just plain text files. And oftentimes, you'll see these things as, it'll have some name followed by a dot, followed by txt, which is kind of the extension that means text. But that's what we're going to deal with, is just files that contain a bunch of characters without any of the characters being like special meaning characters or anything like that. So the way we think about a file, let me just draw a file up here, because life is cheap. As a matter of fact, I'll show you a little file on the computer. Wake up. Don't worry, it'll come back. It'll just take a moment. Wake up, little guy. Yeah, it's time for your starving roll. Here's the file. CS 106, A students rock the house. There can be no doubt about it. Doubt it. I put 2 doubts in there. I don't know why, I just did. All right, it's one of those little things like Springtime in the Paris. Remember that little puzzle? No. All right, let's not worry about it. When something is the beginning and ending of a line, the human brain is just likely to convolve it and think there's only one there. Random psychology lesson for the day. Thank you. Let's move on. Here's a little file. It's a text file. It just contains a bunch of lines of characters. The way we like to think about files is that we're going to process a file one line at a time, and we read files sequentially, which means we tell the computer, hey, here's the file that I want to start reading. It says, okay, I'm ready to read the file, and it starts at the very beginning of that file. And then I will ask the computer line by line, give me the next line of the file, and it'll give it to you as a string, and you can do whatever you want with that string. And then when you go to read the next line of the file, you'll get the next line. So first you'll get CS106A students. The next time you ask for a line, you'll get rock the house. Then there can be no doubt. Then you'll get doubt it. Then you'll get some indication that you've reached the end of the file. Okay, so what does that look like? All right, and how do you actually do this? So you're going to be doing this for, assignment number 4, hangman. So it's a good thing to know. So first thing what you want to do is what's referred to as opening the file. Opening the file basically means you're going to associate some object. You're going to create some object, which is actually something we refer to as a buffered reader. And you'll see an example of that in just a second. You're going to have some object that essentially corresponds to some actual file on your disk. So when you open a file, what you're doing is saying, I'm going to have some object I'm going to create. And when I refer to that object, I'm actually going to tell you that it's referring to some particular file that's on my disk right now. So that's opening the file, is creating this correspondence. Then the second thing you do is you basically read the file. And there's multiple ways of reading the file, but we're going to focus on reading a file line by line until we've read as much of the file as we want, usually the whole file. And then the third thing you need to do is, because you open the file, you need to close the file, which basically cuts this correspondence between the object and the file. It says, okay, I'm done with that file now. This object is no longer referring to that file. This object's I'm going to be done with it. Okay? So in order to use some of this functionality, I'll show you the code in just a second, there's a particular package you need to import called java.io, which stands for input-output.star. So at the top of your program, you'll have an import that it has java just the letters io.star semicolon. Okay, and that'll give you all sort of the file stuff. So how do we actually do one of these things where we're going to open a file, we're going to read its contents, and we're going to close it? It's time to write a little code. So first thing we're going to do is we're going to create one of our friends, the buffered reader. So we're going to have some object that's of type buffered reader, and this is just a class that exists in java.io. That's why you import that package, and you're going to be able to refer to objects of this type. So buffered reader, I'll just call it RD for reader for short. And what I'm going to set that to is a new buffered reader. So this is going to be a new buffered reader. And the new buffered reader needs some parameter. And here's where things get funky. The type of parameter it's going to take is something called a file reader. That's a special kind of object that knows how to attach itself to an actual file on disk. But I need to create one of those. So here's the idiom for how I create it. And the idiom is just sort of the pattern you'll always see in programs. I say new buffered reader, and the parameter that I pass to a new buffered reader is a new file reader. Uppercase R, new file reader. And the parameter that I give to new file reader is the name of the file on the disk. So if the file on the disk is called, like in this example, students.txt, I'd actually give it here as a string, students.txt. I need a space for a few extra parens there, so let me write that a little bit smaller. Students.txt, that's the end of the string. Then I have this paren to close that paren and another paren to close that paren. So what it does, it says create a new file reader, which basically is an object that associates with a particular file on the disk. And that object is what gets passed into a buffered reader. And the buffered reader is what you're going to ask to get line by line. So you're going to say, hey, buffered reader, give me a new line. And it's going to go say, hey, file reader, get the line from that file and get it back and give it to you. Okay? So this is just the standard idiom you always see in the way that it's written. And you can put any string in here you want. As a matter of fact, you can put in a string variable if you want. Now, after you've created that, how do you actually read from the file? So let's have a while loop that'll read in every line of the file. So we'll have a while true loop, because we're going to keep reading until we reach the end of the file. And the way we read this is we're going to read the file line by line, and each line is just a string. So I'll have string line. I tell the buffered reader, this RD object, read line, which kind of looks familiar to you because it sort of looks like reading a line from the user. But in fact, you're passing the read line message to the RD object, which means get me a line from the file. Which file? This file that I created the correspondence with over here. Okay? Now, this will read line by line. Every time I call RD read line, I'm going to get in the next line from the file. What do I get when I reach the end of the file? And this is the crucial thing. One thing you might think is, hey, do you get an empty string? Like, do you get double quote, double quote? No, in fact, I don't, because my file could actually contain empty lines. And I don't want to confuse an empty line in a file with the fact that I've reached the end of the file. So the way I signal reaching the end of the file is, remember, a string is just an object. How do I refer to an object that doesn't exist? Null. So what readLine gives me back, if I try to read a line past the end of the file, is it gives me back a null. It says, hey, there is no string here for you to read. And the way I'm going to indicate that to you is to give you back a null. So I can check that. If line is equal to null, that means I've reached the end of the file. And so I'm just going to break out. Here's my little loop and a half. I'm going to break out of this while loop. And if I got a valid line, I'm just going to print it to the screen. So all this code is going to do is take some file, read it line by line, and print every line to the screen. And since every line is just a string, I can just do a println to the of line, and that will write it out to the screen. Okay? So any questions about this? Now, there's one thing I haven't done yet, right? In my steps over here, I've opened the file because I created the buffered reader. I've read the file. Now I need to close the file. So after I've done reading all the lines from the file, let me move my brace up a little bit to give myself room for this. I just say RD, I refer to the object, and then I say close. And there's no parameters there. And that kind of says, I'm done with you. Thanks, a buffered reader. You did good work. You got me all the lines of the file. And now I'm done with you, so I'm just going to close it off. Okay, question? Yeah, read line keeps track of where it is in the file itself. So every time you read a line, it's automatically keeping track of where it is in the file, and we'll go to the next line. Nice catch. So now there's another thing that happens. And you're like, oh, good times. I'm all ready to read files, right? Almost. The one extra thing you need to know about, and this is the part where it's just kind of one of the stickinesses of programming, is what happens when bad things happen to good people. You're like, huh? What does that mean, Maron? Well, what that means is, let's say I come along and I say, hey, buffered reader, open up students.txt. And some evil person came along and deleted your students.txt file. And so this guy's trying to create a correspondence between this buffered reader and students.txt, and it says, there is no students.txt. I got nothing here. What am I going to do? It needs to signal that back to you somehow. And the way it signals that back to you is it says, whoa, this is just something that I didn't expect at all, and it gives you something called an exception. Okay? So what is an exception? and what's involved with actually getting an exception and dealing with exceptions, okay? So the idea here is what we refer to when an exception happens, right? Like when this guy tries to look up this file and the file doesn't exist, is the term we use is it throws an exception. That's just life in the city, all right? So let's say I'm the buffered file reader and I'm trying to read students.txt and students.txt doesn't exist. So I say, oh, that's an exception. What am I going to do with the exception? I'm going to throw the exception, right? So someone gets the exception. You got the exception. You don't just leave it there. You got the exception, man. All right, what are you going to do with the exception? You caught it. That's important. Hold on to it for the time being, okay? Because it's important, right? That's a valuable commodity. So just hold that exception. Hold that thought, okay? So when an exception gets thrown, there has to be some notion of catching the exception, hopefully. And if no one catches the exception, your program is going to stop executing. Because if there's no one there to catch the exception, that exception is just going to sort of go up all possible functions in your program and say, hey, is there anyone here to catch me? There's no one here to catch me? Okay, your program's done because no one caught me, and I'm a pretty important thing to catch. Okay? That's why I needed you to catch it. I'll set you up for catching it because I know it took a little effort, but it's important to catch it. Just hold on to it for the time being. Okay? So how do you actually catch an exception? Or how do you tell the computer, I'm going to do something that may involve an exception? So you actually need to set it up and let the computer know, hey, I'm going to do something that may involve an exception. The way you say that is you say try. I want you to try something. This thing may throw an exception, so be prepared, but I want you to try it. Inside here, you have your code for file access. And that's whatever you're doing with the file, trying to create a new buffered reader with the file, reading in lines one by one, or closing a file. Anytime you're trying to do something that involves a file access, you need to put it inside this thing called a try that says, hey, I'm going to try this out. It may throw an exception. Now, what happens if it does throw an exception? You have something over here where you write catch. And what you're going to catch in this case is something called an I/O exception, because it's an exception that happens when you're trying to do I/O, or input-output. And there's this EX thing, which is actually the exception. It's that little envelope that you actually catch in your hands. And then you have some code here, which is how to deal with the exception. Okay? So if you are doing something inside here, and someplace, as soon as you get to it, says, whoa, something bad happened, exception, it does not execute any more of the remaining statements inside this block for try. As soon as it gets an exception inside here, it says, whoa, here's an exception. It throws it. Where are you going to catch it? You're going to catch it here, which means as soon as an exception gets thrown, even in the middle somewhere here, the rest of this does not get executed, and it comes over here to this code to deal with catching the exception. If it gets through all of the code where you say, hey, I'm going to try something dangerous, it gets through all of it and it doesn't throw an exception, this code down here is not executed. So this code down here is only executed if an exception was thrown. Okay? So what does that actually look like? Okay? Let's write some code that deals with trying to catch an exception. Just keep holding it. It's a good time. We're kind of, running our program in slow motion. It's kind of like, oh, you've got the exception. And normally you'd be like, oh, catch, here, I'm going to do something with it. Here, we're kind of like, we're taking our time. It's mellow. It's good. Here, I'll give you a little more candy just to keep you awake with the exception. All right, you never thought just by like sitting there you could just accumulate food. All right, so we have private. We're going to return a buffered reader. So this is a function or a method we're going to write that's a private method inside some class. It's going to return a buffered reader. And what we'll call this is we'll call this open file. So the name of the method, let me make this all a little bit smaller so I can fit it on one line. Private buffered reader. And what it's going to get passed is basically some string, which is a prompt to ask the user for the name of the file to open. So that's a common thing you want to do. You ask the user, hey, what file do you actually want to open for reading? So how might I do that? I'm going to start off, I want to return one of these buffered readers, which means I'm going to need to have a buffered reader object in here at some point. So I'm going to declare a buffered reader as a local variable, rd, and I'm going to set it initially to be null, which means I created the buffered reader. At least I created a pointer for it, a reference for it. I have not actually created the object yet. So I can't actually make any method calls on rd yet, right? I've just sort of created the local variable. I'm going to actually create the object in just a second. I'm going to have a while loop here and say while rd is equal to null. So I know that that's going to execute the first time through because I set it equal to null to begin with. And then what I'm going to do inside here, so I have a brace there, is I'm going to say, hey, I'm going to try something that may be dangerous. So what I want to try doing is I'm going to ask the user to give me the name of the file. So I'm going to have string name equals readline, and I'll pass it whatever prompt was given to me as a parameter, right? So I'm just asking, all I'm doing here is asking the user to enter the name of the file, right? And whatever prompt I write on the screen is, excuse me, just whatever was passed in here. So it might have been something like, please enter file was the string. So I'll write out please enter file and ask the user for the file name. Now here comes the dangerous part. I want to create the buffered reader. So I say rd equals new buffered reader. And the parameter I'm going to pass to a buffered reader is new file reader. And the parameter I'm going to give to the file reader is whatever file name the user gave me. So this is just name. So what this is going to try to do is whatever the user gave me, it's going to try to create one of these new buffered reader objects that corresponds to the file with that name that's actually on disk. If that file exists and it creates the correspondence, life is good. RD actually is now pointing to some valid object, which is a buffered reader. If that file does not exist, I've thrown an exception. I say bad times. The user mistyped something or they gave you the name of a file that doesn't exist. Here's an exception, buddy. It's not there. I can't create the correspondence. If that exception's thrown, right, I never created a new object, which means I never returned a value to assign to RD, which means RD still has the value null. That's an important thing. Because if I do this try and the file's not there, I'm going to catch this IO exception EX. And what I'm going to do when I catch that exception, I'm not actually going to do anything with the exception, the parameter EX that's passed in. All I'm going to do is just write a println to the person saying, like, bad file. And then I'm going to have a close paren. And close paren here, another, or close brace for the while loop, so this brace corresponds to the while loop. And if all of this works out, I'll write it right over here on the side. I will return RD. That line would go right down here. Okay? So what does this code do? It says, create the space for an object, or create one of these, the pointers to an object, but set it to be null. It's not pointing to a real object yet. And while it remains null, ask the user for a line. Try to open up a buffered reader to that file. If this works, life is good. I don't execute the catch portion, and RD now has a non-null value because it's actually a valid buffered reader object. And so when I try to do this while loop again, RD is no longer equal to null, which means I'm done with the loop, and I will return this object that I just created, which is actually this object that is a valid correspondence to a file. So that's a very convenient way in one method to encapsulate all the work of opening up a file and getting a valid reference to a buffered reader that refers to that file. If I tried to create this file reader and this file for whatever reason did not exist, an exception gets thrown. If an exception gets thrown, execution doesn't complete at this line, so RD never gets assigned a new value. And it immediately goes to the catch and says, hey, here's the exception. I couldn't find the file. What does the exception catcher do? It says, hey, bad file, buddy. And then it's done, right? It just reaches the end of the catch part, and execution continues. So it comes to the end of the while loop, comes back up here, and RD still has the value null, so it asks the user, hey, enter a file again, and tries to do this whole process again, and you'll get out of this loop when buffered reader actually gets a valid object.
Is it better practice to keep the try block as small as possible?
Yeah, that's a good point. What you want to do is when you're trying something dangerous, you don't want to just tell your whole program. You don't want to say, hey, program, let me put everything inside a try, because I'm going to be doing all this dangerous stuff, and I don't know when I'm going to do it. I might do a little here and a little over there, so put it all inside this huge try block. That's really bad style. What you really want to do is only do as little as possible in the try and say, hey, I'm about to do something dangerous. Let me encapsulate that in one of these things that's a try catch. We refer to it as a try catch block because we have a try and a catch. And as soon as I'm done with the dangerous part, then let me get out of that try block because I need to know that, okay, now I'm not doing dangerous stuff anymore. And the programmer needs to know that when they see the files. They need to understand when you're doing dangerous stuff versus not. Okay? So any questions about that? This notion of throwing an exception? All right. So now, here's the interesting thing that happens, okay? Sometimes when an exception gets thrown, you know what you want to do. Like you want to say, hey, that file didn't exist. I write out bad file and I keep executing. Sometimes you get an exception and you have no idea what to do. You try to, you created this correspondence to students. That worked just fine. And you start reading lines from the file and it's just fine. But before you get to the end of the file, what happens? Your roommate comes along and deletes the file, or like beats your computer on the head and your disk crashes or whatever, and your program's still executing, but your disk is no longer working. This has actually happened before. You try to say, hey, buffered reader, get me a line, and it says, there's no more line. Like, I thought I had the file and everything, but there's no more line. I don't know what to do. What does it do? It throws an exception. Sometimes when it throws an exception, what are you going to do here, right? You just try to read a line. You're like, what? The line doesn't exist? But the file existed. Now you're telling me the line doesn't exist? What am I going to do? Sometimes you don't know what you're going to do. And when you don't know what you're going to do, what you do is you say, hey, you know that exception that got thrown to me? I'm just going to keep throwing it. So throw the exception back to me. And somewhere, now I don't feel so bad about missing you the first time. Someone gets the exception, right? And if I didn't get it, like you throw it to me, I'm just like, what exception, right? And I'm your program. The program just dies. Someone comes along, beats me on the head and says, hey, you didn't catch the exception. You stop executing. But sometimes like someone gets it and they're like, hey, I know what to do with the exception. It's all good, right? And they get something out and they're like, yeah, really all the exception was some clothing I needed you to wear. You didn't know how to wear it. I'm sorry, you're not quite as stylish as I am. So I know how to deal with the exception. Once I know how to deal with the exception, I'm done with the exception. I kind of keep executing from where I'm at. But I appreciate you catching the exception to begin with, and if you didn't know what to do with it, you just keep throwing it along its way. Okay? So one more time, just for throwing it. And to the people around you for getting pelted with candy. All right. So what does this actually look like in code? Okay? So let's look at a little code. Come on, little guy. Wake up. Oh, sleepy Mac, sleepy Mac. All right. So what does this actually look like in code? What's going to happen is here is our little function that we just wrote over there, our method that returned a buffered reader. So this is all the same code. It creates a buffered reader that's null. While it's null, it asks the user for a file name. It tries to create a new buffered reader with that file name. If it doesn't exist, it says, nice try, punk. That file doesn't exist, and it asks again, right? So this is just fine. This is what we wrote. This is an exception that we know how to deal with. We don't actually use this EX portion. You don't need to care about that or whatever. You just say, yeah, I know the file didn't exist, so I'll write out a message to the user and keep executing. Now down here, don't worry about the set font. That's just making the font bigger. I'm going to say, hey, I'm going to call my open file. This is basically a passive-aggressive program. It asks you real nicely, please enter the file name. And if you get it wrong, nice try, punk. That file doesn't exist. And then it says, please enter a file name, right? We'll make no more comments about passive-aggressive behavior. But it calls open file, it passes in this prompt, and what it's guaranteed to get back is an RD object that is a valid file, right? Because if it didn't get a valid file, it just keeps looping here until it got a valid object that it could actually correspond, has a correspondence to the file. And you're like, oh, that's great. Now I need to read the file. Reading the file is a dangerous thing to do because I'm referring to this file and I don't know if something bad will suddenly happen and the file will go away. So I put this inside another one of these try-catch blocks. So not only do I have a try-catch block for opening the file, every time I try to read the file or potentially close the file, I need to have one of these too. So this guy comes along and says, okay, I'm going to have a while true loop and read all the lines of the file, kind of like Meron showed me before. So I'll have this variable line that I just read a line from the file. If that line is null, then I know I've reached the end of the file, so I'm done. And I break out of the while loop, and I will come here and close the file. Always remember to close your file. It's just good practice. If the line is not null, I'm just going to write it out to the screen. I'll say read line, and I'll write out inside little brackets just so it's clear what the beginning and ending of the line were, the line that I read in. Okay? And I'll just keep doing this, and when I'm done and I don't get an exception, I close the file, and I will skip over this catch portion and just keep executing, which means my program's done. If, however, while I'm reading the file, I say read line and it just doesn't exist, I come over here to the exception and I say, hey, I got this IO exception. I don't know how to deal with that, right? I don't know how to deal with the fact that I just read a line, it doesn't exist. So I'm just going to throw an exception to someone else. So what I do inside here is I will throw a new exception. And the exception you will always throw, if you don't know which exception to throw, which is most of the time you won't know which exception to throw, is something that we call the error exception. So you say, hey, I got an exception. I don't know how to deal with it. Maybe someone else who was trying to access me put me inside a try-catch block. So I'm going to throw an exception up to them and see if they can catch the exception. And the exception I'm going to throw is an error exception. And when you throw an exception, it has a parameter, and that's just the exception object that you're throwing along. You actually got some exception object passed to you when the exception was thrown. You didn't want to look inside. You didn't want to deal with it. And as a matter of fact, you don't need to look inside or deal with it. All you're going to do is just continue to pass that exception object up to the person who may have called you. Okay? So when you throw an exception, execution would stop in the method that you're at that point where you throw the exception. The method will end, and it will throw an exception up to whoever called this method. Okay? Unless this happens to all be inside some other catch block inside here, in which case you'll catch the exception yourself. But if you're not trying to catch the exception yourself, it'll just get passed up and someone else will catch it. Okay? So any questions about this? Here we know how to deal with the exception. Here we don't know how to deal with the exception. And if you want to actually be able to pass an error exception, that's something that's defined in this thing called ACM util. So it's an exception that's defined in the ACM libraries. You should import acm.util.star to be able to throw one of these error exceptions. Okay? So this is, let me just run this program just so you can actually see that it works. This is another file example. And then I will show you something that's extremely cool, which is basically in 10 lines of code, you can copy files, doing it all in Java. And you're like, yeah, Maron, but I can copy files in like 4 clicks of my mouse. Yeah, what if I just took your mouse and just busted it, right? Then what would you do? You're like, yeah, then I'd write a Java program to copy a file. Don't force me to bust your mouse. One of my other mice busted last night. It was just a harrowing experience. So I want to enter the file name, and I say, oh, the file name is, what was that called? Was it called Stanford? Stanford.txt? No. Oh, it was called students. I keep pressing the A. Yeah, I can't even type anymore. Wasn't it called students? No, it was called students.txt. Oh, I forgot the S, students.txt. And then when it finally gets a valid file and creates the correspondence, notice it's reading the lines from the file one by one, and it just got them as strings, and it's printing them out. Okay? Any questions about that? So besides reading files, sometimes in life we also want to be able to write files. So here's the quickie way to be able to write a file. Okay? It's very similar. It's actually writing a file is even easier than reading one, if you can believe that. And you're like, but Maron, reading one is pretty easy. Yeah, it is. And writing one's even easier. So it's just that much cooler. If I can find my chalk, it'll be even that much cooler. Here it is. What you're going to do is, guess what? You're going to open a file to write. This is something, rather than using a buffered reader, we call it a print writer. You will create a print writer object. 2, you will write to the file. Unlike reading from the file where you use readlin, it's very easy to write to a file. You just do printlins to the file. You use println, but you're actually going to be passing println to some object here. What object? Your print writer object. Okay? And the same ways you've used println to write on the screen, you can use it exactly the same way to write to a file. And when you are done, you will close the file. Gee, that looks real familiar, right? So let's actually see what that looks like in code. So what I'm going to show you is a little program that copies a file, line by line. So once again, here's the exact same function we wrote before to open a file for reading. So this has our buffered reader stuff and our little while loop and keeps asking for file names until we read the file. So it's exactly the same code. We're just reusing the code. That's part of the beauty of code reuse, right? What we're going to do here is we're going to open a file by asking the user to enter a file name, and this is the file that's going to be our reader. So our object is RD. Now we're going to create a file that is a object which is a writer. So we're going to try, because we're going to do something dangerous. Creating a file is just as dangerous, or writing a file is just as dangerous as reading one. As a matter of fact, in some sense, in a more esoteric way, it is more dangerous. Why is it more dangerous? Because if you try to tell the computer, write to a file which already exists, what's it going to do? You might say, will it tell you that it already exists? Will it try to give you a different file name? No. It'll go smash the file that exists there to bits and write a brand new file. Which means, yeah, if you're overwriting students.txt, not a big deal. If you're overwriting your word processor, big deal. Be careful what file names you give when you are writing, because if that file name already exists, it will get rid of the one that's already there and overwrite it with a new one, which is whatever you happen to write into it. Okay? So print writer, we're going to create a new writer, and we want to, inside a print writer, just like we had this little thingy up here where we had a buffered reader, and a buffered reader used a file reader, over here when we create a print writer, and this is all in chapter 12 of the book, so you don't need to worry about scribbling this down quickly. A print writer, you say new file writer is the object you create and pass to a print writer, and you give it a file name. Here you could have given it, like a string variable or whatever. Here I've just put in directly copy.txt. So the thing I'm going to create is a file called copy.txt. All your files need to be in the same project as your code. So that's where new files will get created. That's where when it looks to read a file, that's where it's going to look as that same file that has your project. So I have a while true loop. What am I going to do in my while true loop? I'm going to read one line at a time from my input file, from my reader. If my reader has no more lines, I get a null and I say, hey, I'm done reading. I'm going to break out of the loop. If I'm not done reading, I've just gotten a line, I'm going to write that line to the screen using println. So println without any object over here writes to the console because this is a println that is being called on the console program, and it writes to the console. When I do wr.println, that's sending println to the the print writer object, and it's writing out the line. So it's saying, here's this line. Hey, print writer, write this out to the file that you correspond to. It says, oh, OK, I'll go write it in copy.txt. And I keep looping like this. I get a new line. If it's not the end of the file, then I write it to the screen and I write it to the file. If I go through this whole while loop and finish off everything, so I finish the whole file, I get to where line equals null, I say, hey, I'm done reading the file, so close the file to read. I'm also done writing the file, so I tell the writing file, the print writer, to close itself. And this whole time, if something bad happens and I get an exception, I catch the exception and say, I don't know what to do with it. I'm just going to throw it to someone else. Okay? And that's the whole program. That's all the code you need to copy a file. So let's run this and just make sure it actually works. Operation in progress. And just to show you that I'm not lying, let me cancel this for a second. We'll open up some folders. Notice no copy.txt in here. Here's the little project file that I have. Okay? There's my copy file class, my copy file.java file. Here's my students.txt file. No copy.txt file. Now, magic. All right, we run. See, I had to tell you that because I could have just cheated. I could have been like, yeah, I just typed up the copy.txt file. Running. Oh, come on, you can do it in your glowing blue. I love the glowing blue. It's fun. Copy file. Please enter file name, students.txt. I'll spare you the incorrect file names. So it's it says copying line. It writes out all these lines to the screen. Let's see if it actually exists. Oh, copy.txt. It's warm, it's fuzzy, it's fun. Now, if you look over here, just wondering, you might look in your project and say, hey, I don't see, I thought this shows me everything in my folder. I don't see copy.txt show up here. Yeah, you go up here, you right-click, you pick refresh. Ah, copy.txt. And there it is. Looks identical to students.txt. There you go. All righty, any questions? Then I will see you on Monday.